Welcome Trio. Today we're going to go over solving exponential equations, and the way that you do that is you use logarithms, but let's see how we can do this problem. So we have 3 times 6 raised to the x power minus 1 equals 647. You have an exponential equation whenever the variable is in the exponent position, which it is in this case. So we're going to solve it by isolating the variable. First thing we need to do is move the 1 over. So we add 1. We get 3 times 6 to the x equals 648. Now we divide by 3. Divide by 3. 648 divided by 3. 6 to the x equals 3 goes into 6 twice. 3 goes into 4 once. 1 left over. 3 goes into 18 6 times. We get 216. 6 to this, to what power equals this? This is actually the same as saying 6 to the x equals 6 cubed. 6 cubed is 216. So when the bases are the same, we can equate the exponents, and x equals 3. This one is done. I'll be back with another example. Thank you. Welcome back. We have a new example. Let's try this one out. Again, we're solving exponential equations. You have an exponential equation when the variable is in the exponent position. It is here, so this is an exponential equation. Let's see how we solve it. First thing we're going to do is move the 1 over. This is 80. Now, in order to isolate the x, we got to move the 5 over, so we're going to divide by 5. We can't multiply through. A common mistake is to multiply the 5 times the 2. You can't, because you're raising the 2 to some unknown power. So you can't multiply this and make 10. We're going to divide by 5. $80 divided by 5 is 16. 2 to the what power makes 16? We can rewrite this 16. So we have 2 to the x equals 2 to the 4th. 2 to the 4th is 16. Because the bases are the same, we can equate the exponents and say they are equal. X equals 4. And we're done with this example. I'll come back with one more example. I'll be right back. Okay, so now we're back with another example. Here's an exponential equation. Let's try to solve it. Again, first thing we're going to do is isolate the variable. So we're going to move the constant term. And that means minus the 3. So 2 times 5 to the x equals 60. Again, we can't multiply this because we're raising the 5 to some unknown power, so we can't say 2 times 5 is 10. We got to get rid of the 2 by dividing by both sides. Half of 60 is 30. So we're saying 5 to what power equals 30. Well, 5 isn't going to work evenly, so now we have to use logarithms. So in order to do that, we can take the log of both sides. And when you see the log with no base in the bottom, no subscript. This is called the common log. And so here we had 5 raised to the x equals 30. Here we have the common log of 5 to the x equals the common log of 30. Using the rules of logarithms, we can move the x over. X times the common log of 5 equals the common log of 30. Divide both sides by the common log of 5. Whatever you do to one side, you have to do to the other. So we're going to divide by the common log of 5 rather. X is approximately 2.113. So when you're working with logarithms, you don't usually come out to a nice number like we did in the other examples. Here we have an approximation, and it's nice to round to 3 or 4 decimals depending on what your teacher wants. Here we round it to the 3rd decimal place. That's the 3rd digit after the decimal place. So 2.113 is our answer. I'll be back with one more example. Thank you. Welcome back. Here's our last example for the day. We have 5 times e raised to the x minus 1, all equal to 100. Notice that it's not just raised to the x, it's raised to x minus 1 or 1 less than x. This is an exponential equation because the x is in the exponent position. Let's solve this problem. First thing we need to do is divide by the 5. So 5e to the x minus 1 equals 100. Divide by 5, divide by 5. E to the x minus 1 equals 20. Now, we still have an exponential equation because we have x in the exponent position. And we have x minus 1 in the exponent position. E to the x minus 1 equals 20. E is called the natural number. So in order to solve this problem, we need to use logarithms, but we need to use a special logarithm called the natural logarithm. And we take the natural logarithm of both sides. So whatever you do to one side, you have to do to the other. The natural log of e to the x minus 1 equals the natural log of 20. One of the rules in logarithms is that the exponent becomes the new coefficient. And another rule here is that the natural log of e becomes 1. So we just have x minus 1 times 1 equals the natural log of 20. And anything times 1 is itself. So we have x minus 1 equals the natural log of 20. We want to solve for x, so we need to move the 1 over. X equals the natural log of 20 minus 1 actually becomes plus 1. So now we can find the answer, and it's going to have to be in the calculator to use the logarithm function for natural log. We plug it into a calculator real quick, and let me just see what we get. We get approximately, final answer 3.996. Okay, thank you. We're done. Go Trio.